I'm Garth Gibson, and I'm here to recognize the loss of an important member of our community. Erik Riedel left us this year, about 6-7 months ago. Tomorrow, those of us that want to spend some time reminiscing, sharing stories, and spending time with his family are welcome to come to the Alameda Room, 6:30 p.m. tomorrow evening. You can either look at this picture for the family from 15 years ago, or you can look down there where they are now. It'll be an event for people who have known Erik in his many different environments. For those of you who don't know Erik, I want to point to his record of service, and I encourage you to emulate it. In 30 years in the academic community, 25 years in the industry community, PC co-chair and in many different events, but in this event in 2008, and 15 years on the steering committee, and in hot storage in 2009, and 15 years on the steering committee at SNIA, the Storage Networking Industry Association, on the Technical Council, and on various standards committees, some of which got to standard. It's a lot of work in all of these things. For me, I go back to when he was a graduate student, and I did work with him on his PhD. Active disks was the title. May not mean anything to you today, but the big trend is something you will recognize, that electronics continues to put more transistors and deliver you more computing performance for less money. So you replace hardcore electronics with processors and write programs on them. Therefore, you could do that inside a device. How should you use it, and what can you use it for? And 30 years ago, he looked at that question, but did it a way I really liked. He took an important application, databases, an important real production open source database, Postgres, and he found where you could find enough information to decide what to pull out and offload to the device, and characterized what kind of benefits you could get. Because the cost constraints, and at the time the amount of computing, you couldn't spend a lot of cycles on it. You couldn't have a large footprint of state, and you had to reduce the amount of bandwidth that you were going to use after the computation by a lot. That's gotten better since. So today with a flash, you can put an FPGA on the system. You can look at many banks of the flash at the same time and do a lot of reduction. And so this idea that he characterized with a few people that did it in networking as well, and a few people that did it at other universities, this set an architectural model that we're still pursuing. For example, I'm showing the Samsung device, which is doing that today, and the open source interface, NVMe CSD, for computational storage devices, or disks, or whatever we call the computational storage thing. Lately, Erik has been looking at carbon footprint. He was a member of the Green Storage Working Group for quite a while. I think he helped start it. And I wasn't in the room, but I saw his Storage Developers Conference talk, which you can find on YouTube, you can find on the SNIA website. He talks about the range of things you can do when you focus on trying to improve characteristics, the engineering way of thinking. The key one that he was talking about, that as I understood it, was to lower the carbon footprint effect of IT equipment. And if you're doing GPUs these days, you're getting a lot of pressure on this one. But the key idea was that the equipment we use, the majority of its carbon footprint is accrued in the construction of the equipment, long before you use it. And if you're an owner and you want to operate on it, you can only do so much improvement by the time you've bought it. What are you going to do about the cost up front? And yes, you can help people do better mining, and you can help people do better smelting, but you could also say, this equipment lasts a lot longer than I normally use it. Most of the components in this system are going to last at least 10 years, and many of them are contractually obligated to be able to be replaced for full 10 years. So they started looking at scavenging equipment and coupling it with replacements for whatever you could use in order to offer components, complete systems, which they built that could be lower cost because they reused working equipment, and amortize the original construction penalty for construction. Fabulous stuff. I encourage you to listen to the video. Besides, he's entertaining to listen to. All right, so after Erik passed, the steering committee for FAST, realizing the loss to the community, decided to rename the Best Paper Award the Erik Riedel Best Paper Awards that we will just get to now. And I thought this is really great, and I look forward to talking to anyone who wants to come talk to us tomorrow evening to talk about Erik Riedel and the things he's done.